Okay, Azaan. Okay, fine. So, in case of myopia, in the correction of myopia, so see with respect to this lens, with respect to this concave lens, where is the object? Object is here at infinity. Okay, this is the object. This is the position of object, and object is at infinity from this lens. Okay, so for the correct for calculation of the power, for calculation of the power, uh, the object for the for calculation of the power for myopia. Okay, uh, the object distance we take infinite. Okay, the object distance we take infinite, and the image distance we take the near point of the eye, near point of the myopic eye. So okay, now you can see this eye has the myopia, and this eye want to see the object at infinity. Okay, means the distant object. So basically, for the correction of myopia, there is a requirement of concave lens. So with respect to this lens, this object will be infinity. So you can say the object distance we will take infinite. Okay, and with respect to this lens, so the object is here and image is formed here. And what is this point? This is the near point of this eye. So basically, we will take the near point. Okay, we will be, we means the image distance. We will take the near point. Okay, so now you can see here. You can see calculation of power for concave lens to correct myopia. Okay, for the concave lens, we will have to calculate power. Suppose I have this spectacles. So in this, these are the lenses. So these lenses have some power. Okay, these lenses have some power. Okay, so basically that power we want to calculate. So for that, u we take infinity, and we take the uh, far point. Okay, we take the far point. Okay, basically here this is not the near point. This will be the far point. Okay, this f is the far point of this eye, means up to this distance, this eye can see. Okay, so this is not the near point, sorry, this is the basically far point. Okay, so we will take the near point, oh sorry, far point. Okay, Azaan?
Yes, sir.
Very easy questions will be there. Okay, lens formula 1 upon v minus 1 upon u 1 upon f. What is u? U is the object distance from the lens. Object distance. What is v? Image distance. What is f? F is the focal length. Focal length of concave lens. Concave lens. And power is given by 1 upon focal length. And focal length we will take in meter, then we will get the power in diopter. The unit of power is diopter. So remember this point. Now we will solve this question. This question from NCERT. Okay, so they are saying the far point of the myopic person is 80. Far point is 80. Myopic person is 80 centimeter in front of the eye. What is the nature and the power of the lens required to correct the defect? So far point of this myopic person is 80. Means what is given? Image distance is given, and this is, they are saying in front of the eye. Basically, this will be the eye. Suppose this will be the eye, and here will be the eye lens to correct. This is the defective eye. This is the lens, and this is basically the far point of this eye, that is B, that is equal to 80 centimeter. Okay, and this is in front of the lens. Okay, so you can say incident. Okay, fine. Basically, this is in front of the lens, so we will take this as negative, minus 80 centimeter. We will take now. What we take the object distance? This eye, have the defect, and this eye want to see an object which is at far point. This object is at far point. This is the object. This object is at far point. This object is at far point. Far point means the object is at infinite. Okay, so this is the object. So rays from this object will be in this direction. This is the direction of the incident rays. I have told you, if we are measuring the distance, sign convention, recall the sign convention. If we are measuring the distance in the direction of the incident ray, then it is positive. But here, from the lens, we are measuring the, okay, from the optical center. I have told you all the distance will be measured from the optical center in the sign convention of the lens. So we are measuring the distance from the optical center. So this distance, we are moving in this direction, means like this. So we are going in the opposite direction of the incident rays. Okay, so that is why V is negative and U is infinity. So focal length we can find now easily, 1 upon F from the lens formula, 1 upon F, 1 upon V minus 1 upon U. Okay, so 1 upon F is equal to 1 upon U, means 1 upon V, 1 upon minus 80. Okay, and this is 1 upon infinite. Azaan, can you calculate this value? Basically this is 80. Can you calculate the focal length?
I will try, sir.
Okay, try just fast. Basically, we have to find the power of the lens, and they are asking the nature of the lens. So lens is concave lens. Okay, lens is concave. So nature of convex is concave lens, the diverging nature. Okay, so 1 upon focal length is equal to minus 1 by 80, and 1 by infinity is 0. 1 by infinity is equal to 0. So focal length will become minus 80 centimeter. Now from here you can calculate the power. So basically, for calculating the power, you will put the focal length in meter. Okay, so this is your 1 upon focal length is minus 80 divided by 100. So it will become power is equal to 100 by 80, and this is of negative. So it will 10 and 10 will be cancel out. So it will become 5 by 4. So I think it will be 1 point minus 1.25 minus 1.25 diopter. Okay, so this will be the power. So power is negative. Okay, now they are asking what is the nature. So nature of the lens. So in, for the correction of the myopia, which lens we use? Concave lens. And
Yes, sir.
concave lens has a diverging nature. Concave lens has a diverging nature. Means concave lens diverges the rays. Diverging nature. And what is the power? After that they have asked power of the lens required to, so power is minus 1.25 diopter. This is the power. Now this is the correction for the myopia. Now we will see the correction of the hypermetropia. We will calculate the power of a lens to correct hypermetropia. Can you tell me which lens will be used to correct hypermetropia? Concave or convex?
Convex.
Convex. Okay.
Convex.
Now first see hypermetropia. What we will take the object distance and what we will take the image distance. Okay. Now you can see here where what this is the object basically. Okay. This is the object the eye want to see. So object distance will be the near point. In this case, the object distance will be the near point. Okay, and where the image will be formed, object distance will be the near point of the normal eye. Okay, so this is the near point for normal eye. Okay, for normal eye. Basically, this hypermetropic eye want to see this object here. Okay, this object here, and this is at a distance of 25 centimeter. Okay, and finally, where is the image is formed? Finally, where is image is formed? Image is forming at the near point of this hypermetropic eye. Okay, near point of this hypermetropic eye. Okay, so basically uh, object distance, you will take the near point for the normal eye, that is equal to 25 centimeter. Okay, and image distance, you will take the near point of the hypermetropic eye. Okay, near point of the hypermetropic eye. Finally, the image formed by this lens is here. This is the image. So this is the image distance basically. Okay, so this is V, image distance. So you can write here calculation of power for the calculation of power of a convex lens to correct hypermetropia. Basically, we use the convex lens, and object distance we take normal near point. What is normal near point? That is 25 centimeter. And why we are taking minus 25? Okay, you know the reason? Because the object is in front of the mirror, in front of the lens. Okay, and image distance we will take the near point of the hypermetropic eye. Near point of the hypermetropic eye. So finally, the convex lens is producing the image at the near point of the hypermetropic eye. Okay, and the eye want to see the object at the normal near point, that is 25 centimeter. So this is the question. They are saying the near point of the hypermetropic eye is 1 meter. Near point of the hypermetropic eye is 1 meter. Basically, near point given of hypermetropic eye, and that is 1 meter. So finally, where is the image forming? At the near point, the image forming now of the hypermetropic eye. So it will be V is equal to minus 1 meter, and it can be written as minus 100 centimeter. What is the nature? So nature we can tell the lens is convex lens. So convex lens is a converging lens. Okay. Power of the lens required to correct this defect. Assume that the near point of the normal eye. And what is the U? Object distance we take minus 25 centimeter. So from here we can find the focal length. Okay. So from here we can find the focal length. So focal length will be 1 upon f is equal to 1 upon v minus 1 upon u. So 1 upon f, what is 1 upon v? Means minus 1 by 100, minus 1 upon u means minus 1 by 25. So it will become 1 upon f is equal to 1 by 25 minus 1 by 100. So basically here you can take 200 as you can take 150 200 LCM. Okay, so here will be 8, here will be 2, so it will become basically 6 by 200. So focal length finally you will get 200 by 6, and it will be 100 by 3 centimeter. Focal length this time you are getting positive focal length. Now when you will convert this focal length in meter, so you will divide this. This is 100 by 3 and 1 by 100. So its focal length will become 1 upon 3 meter. Now power of a lens is given by 1 upon focal length in meter, 1 upon of focal length in meter. And what is focal length in meter? 1 divided by 1 by 3. So basically power of the lens you will get plus 3 diopter. So power of the lens. So now here write what is the nature of the lens. What lens we are using to correct hypermetropia? Convex lens. So convex lens has the converging nature. We know na convex lens always converges the rays, and power of the lens is equal to plus 3 diopter. The lens that the convex lens that is used for the correction of hypermetropia will have a power of plus 3 diopter. Okay. So this is finished. Now there are two two more defect. One is presbyopia. Basically, what is presbyopia? In old age, what happens? The ciliary muscles becomes weak, and due to that the functioning of the eye lens is not proper. So that the eye loses the power of the accommodation, and this defect is known as the presbyopia. So basically, in old age, due to the ciliary muscles becoming weak and eye lens becoming inflexible, so the eye lenses, so eye loses the power of accommodation. Because of that, an old person cannot see the nearby objects clearly. This leads to the object called presbyopia. And there is another defect, cataract. Cataract is basically on the eye there is a thin layer, white color thin layer. Okay, due to that the eye cannot see properly. That is known as the cataract. So basically cataract is the medical condition in which the lens of eye becomes cloudy, okay, due to the formation of membrane over it, resulting in blurred vision is called cataract. Okay, so there is presbyopia. So what happens in the presbyopia? In old age, the ciliary muscles become weak. And what is the function of the ciliary muscles? To increase or decrease the focal length. Okay, so increase or decrease the focal length of the eye. So what happens for what is the power of accommodation? Power of accommodation is the ability of the eye to focus on an object. That is known as the power of accommodation. But due to the ciliary muscles becomes weak, due to the ciliary muscles become weak, the eye cannot focus properly. Okay, why? Because the focal length cannot be adjusted properly. Due to that, this defect occurs, and basically in this defect, the person is not able to see nearby objects. Okay, so this is like just like hypermetropia. And another is the cataract. In cataract, there is a layer formed on the surface on eye. Okay, a white type color layer formed on the eye. Okay, so basically presbyopia can be corrected by the same method as we used for the hypermetropia by using a convex lens. For the cataract, there are other solution, like there are operations and surgery also. Okay, for the cataract, because in operation what the doctors do, they just remove that layer, okay, from the eye, so that the eye becomes the normal. Okay, so okay, just note down, Azaan. So this is finished now. After that, we will study the glass prism in two
Okay,
lectures.
sir.
In I think this chapter will be finished. And remember, this is a lens formula. Note down. So Azan, do you want to go early today?
Yes, sir.
Okay.
Sir, can you scroll down?
Uh, okay. After that, we have done this question. Just wait a minute, Azan. No, it's fine.
Sir, scroll down, please.
Okay.
Done, sir.
Okay. Okay, write down this.
Done, sir.
Done. Okay.
Sir, scroll down, please.
Oh. Azaan completed.
Yes, sir.
Okay, just write down this. These are
Okay, sir.
so you can just add one point here. Correct it in the same way as hypermetropia. And this is corrected by surgery. And this also comes usually in old age. Usually comes in old age. Usually, okay.
Okay.
Azaan completed.
Yeah.
Hmm. Completed or
Yeah.
not? Okay, see, this is cataract. This is the layer, white color layer over the eye. So due to this eye lens have becomes cloudy due to this membrane, and so that the image is not images properly. But this there is a blurred vision. Okay, you can see this is a membrane here. Azaan, do you want to go now?
Yes, sir.
Okay, so got it? How to calculate the power?
Yes, sir.
Hmm? Okay,
Yes, sir.
so in the next class, we will just continue from here, and in the next class, we will start glass prism. Okay, and glass prism means
Okay, sir.
there we will study dispersion of light, where the light will be split it into
Okay.
the seven color, and rainbow and all these things we will
Okay,
study
sir.
there. Okay, fine.
Okay, sir.